Hello all, my name is Rahman and welcome back to my YouTube channel, and in this video we are going to learn about how to write and analyze an algorithm. If you remember, in the first two videos we have talked about the introduction, and in the last video we have talked about the characteristics of an algorithm in the detail. We also talked about prior analysis and posterior testing, and we also talked about the difference between algorithms and the programs. Now we know that how to follow the rules for writing and analyzing an algorithm. Now let's learn how to write and analyze an algorithm. So let's go ahead and get started. Now guys, let's learn how to write an algorithm. If you remember guys, in the last video we have talked about the characteristics of an algorithm, which means that we have to follow some rules while writing an algorithm. Now there we learned about how we have to clearly define the algorithm input, right? First of all, you have to give the input, and the input should be clearly defined. That is the first rule that we need to follow. Now guys, here we have the first question for writing an algorithm, and that is, in which programming language can you write an algorithm? So as I said you in the last video, in whatever programming language you like Java, Python, C hash, C++, or whatever you want, you can write it. But here I'm going to do that in the Python itself because I have the knowledge of Python. Now here I am going to write a Python program which swaps two numbers. Now here in algorithms, while writing an algorithm, we don't have to define the parameters. Right now we are not going to define the parameters. And guys, as I have just said that the algorithms should be clearly defined. Now let's say that we have a value, okay, and that is test, or let's say that we have the value and that is test. Let's say now the test is going to be equal to a. Now let's give here some values, and here is a equal to 10 and b equal to 5. Okay, so this is a is equal to 10 and b is equal to 5. Now we have a value, we created a variable known as test, and in that variable we are storing this 10, and that is a, right? So which means we are calling it that 10 number. Now here I am going to create one more variable known as a. Okay, now we know the value of a equal to 10. Now here we have the a equal to 10, but here I am going to redefine that, and that is a is equal to b, which means that a is equal to 5, right? Now we know the value of, now the a value has changed here. So the test, in the test we have the value of 10, right? But it also changed because here we have written a is equal to b, which is going to be the p is equal to 5, which is a equals to 5. Now here I am going to write this one, which is equal to test, st. Now guys, finally I am circling this round. Now first of all, here I have defined the value of test, and that is a. Test is equal to 10, which is 10. Okay, now we are calling this a, and the a is equal to b, and that is the 5. A is equal to b. Now the value of a is b, remember that. Now we are giving that b is equal to test. Now what is the value of b? That is 10, right? So this is called as swapping two numbers in Python. So I have just explained you like this. Now here we are not going to create any data types or any parameters while doing this one, right? So in algorithms we don't do that. If you want to do that, not right while writing an algorithm, you should not do like that. You can do that while just writing a Python program, while when you want to swap two numbers. So this is a Python program, so this is the way that we swap two numbers. Now first of all guys, we have followed one rule, and that is that should be clearly defined. So now you may have understood this one. The value of test is 10, okay, and the value of, now the value has changed, and the value of a is 5. Now the value of b is not 5, the value of b is 10, right? So these are, now the value of b is 10 and the value of a is 5. Now let's learn how to analyze an algorithm. Now guys, there are several ways with which we can analyze an algorithm. So the first one I wanted to show you is that time complexity, that how much an algorithm, that how much time it should take, how much time it's taking. So the first one is time complexity. This involves determining the amount of time it takes for for an algorithm to run as a function of the size of input, common time, complexity. So this is what the first this is the first way with which we can analyze an algorithm. Now coming to the second is space complexity analysis. This involves determining the amount of memory used by the algorithm as function of the size of the input. Now we can see the size of the function as, and we can also see the size of an input. Now let's say that we have written a Python program which has around 50 lines of code. Okay. Now there we can analyze that how much we can analyze that function, that how much space it has, how much line it has, by seeing there. Right here also this is what the space complexity, so this is known as space. Okay. Now the third one is asymptotic analysis. This involves analyzing the algorithm's performance in the limit as the size of the input becomes arbitrarily large. Now let's say that we have the around 100 lines of code. Okay. Now if I have written that 100 lines of code, and we need to check whether how its performance. Now let's say I have in the 100 lines of code I have created a snake game. Okay. Now while playing the snake game, how much boxes it have, how it is working on, all of those stuff it should have, right? Now this is what is known as performance. So this is one more way with which we can analyze an algorithm by finding that what is its performance, right? The third one is, and the fourth one is empirical analysis. So here I forgot to write the sympathetic analysis. P TOCIC, sympathetic. So the mistake I have written. Now here the fourth one comes is empirical analysis. This involves running the algorithm on a variety of inputs and measuring its performance. Okay, so this involves running the algorithm. It's going to run an algorithm and then the algorithm on a variety of inputs. So when we give the input, then it's going to write the input in a different way. Now here when the starting of the video, what I see is hello all, welcome back to my YouTube channel. Now the one more thing that we can do is, hi everyone, my name is Abdul and welcome to my YouTube channel. I can say that. So here it means the same but in a different sentence, in a different meaning. I am saying that, right? So this is what this is what the empirical analysis do. So it tests the algorithm on a variety of inputs and measuring its performance. It also measures the performance and then it also tests that on the variety of inputs such as running the time and the memory usage. And the fifth one is for worst case, average case and the best case analysis. Okay. Now here we have the empirical analysis, EMPIR, empirical analysis. Okay. Now this is what the one thing. Now here we have another thing, that is worst case, average case and best case analysis. This is the fifth one. This is W. This is the worst case. This is the average case, and this is the best. Sorry, this is the best case analysis. Okay. Now what happens is, in the worst case, in the average case and the best case analysis, what it does is this involves the determining the maximum, average and the minimum amount of resources required by the algorithms to solve the problem. Now let's say that we have to write a Python program. Now for writing the Python program we need an IDE, okay, that is integrated development environment. For writing that Python program we need some tools, okay, like we need a laptop or a computer, whatever, okay, and then we need a software like Windows, Mac OS, whatever, and then we need some of the things like the IDE, then Python should be installed, and all of those stuff we need, right? Now this is what the worst case, average case and the best case analysis. So as I've given the examples of the IDEs, the software, the laptops, so those are the resources that I want for writing a Python program, right? This is the fifth one. Now the sixth one is approximation analysis. This involves determining the error rate. Okay. Now when we write a Python program, there we are going to get errors if we have done any mistakes. Now it's going to find that, let's say that I have created a website where I have a lot of errors. Now it's going to find the error rate, that how much errors that I got. So if there is any of the algorithm, then it's going to work there. So it's going to find the rate of an algorithm, error rate of an algorithm, and then it's going to work on that. So this is how we write and analyze an algorithm. Now guys, let's come back to our previous example. Here we have an algorithm, and here I have explained you that how to swap two numbers or arrays. Okay, now let's say that how to analyze this algorithm, right? So from the time we learned that how to write, like how to what are the things that we should do when analyzing an algorithm. The first one and that I have said here is the first one that I have said here is that the time complexity, and the second is the space complexity that we need here right now. I'm going to remove this stuff here right now. Now here we need this stuff, but here how do we find the time and the space complexity? Okay, now let's say that for each letter, for each letter, it's taking 1 unit of time, 1 unit. Okay, this is the first one, this is the 1 unit. So this is the second unit, and this is the third unit. So this is known as 1 to 3, not 1 to 3. So these are the units that we need here, and the last one that we are getting here is 3 units here we are getting, right? So here this is known as, this is how we do the time complexity for this one. For each one we need this one, but so like this also we are going to do for the space complexity. Now this is all for this video, and in the next video I'm going to talk about in detail like how to write an algorithm, do all of those stuff. So thank you for watching this video, and I hope you like the video of how to write and analyze an algorithm. So don't forget to like, share and subscribe, and I will see you in another tutorial. Thanks for watching. Thank you. Bye bye.